Welcome. Today we're going to do section 1.2. Section 1.2, it's called integer exponents. You should see the previous video about properties of exponents. If you don't see the video with properties of exponent, you might be a little lost. So seeing the video, I think it's going to be helpful. So I do recommend it. But if you don't want to see the video and you just want to continue here, that would be fine. These are the properties of exponents that you are responsible for knowing for class. You will be tested on understanding them. We have something that is called the product rule. The product rule says if we have the product of two different, we have the product of the same base number with two different exponents. Basis means the letter A. So A is called the base, and the exponent, it's the M and the N. Okay, as you can see, if they have the same base, we can add the exponents. And so here's an example. If I give you x to the fifth times x to the third, since we're multiplying, we can add the exponents. So the answer will be x to the 8th. In case I forgot to mention, okay, so this is considered to be, for example, the base here. The base is x, and that's the exponent. So then you know what we're talking about. The exponent is m. And if I give you another one, and so then this is the base. The base here again, it's x. But in this case, the exponent is n. If they have the same base and you're multiplying them together, you can add the exponents. That was property number 1. That's what we call the base, basically. Okay, that's called the product rule. Now, the quotient rule says if you have a fraction and the bases are the same, then we can subtract the exponents. It will be 8 to the m minus n. And here's the example. The example is x over 9 over x to the 9 over x to the 5th power. You subtract the exponents and the answer will be x to the 4th. Power rule number 1 says I have a to the m in parentheses raised to the n power. We can multiply the exponents out. So I multiply the m times the n. And here's an example, x to the 3rd in parentheses raised to the 4th power. When you multiply 3 and 4, that becomes x to the 12th power. Here's power rule number 2. It says in parentheses a times b raised to the n power. You multiply the exponents. We're assuming here that the exponent of a is 1 and the exponent of a is 1 and the exponent of b is 1. Let me go ahead and try that again. So the exponents right here are 1. You multiply them out and you get a to the m times a to the n. And if they have the same base, then you can add the exponents. But if they do not have the same base, you do not add the exponents. Okay, a small mistake here. It's supposed to be a b to the n. Here's the example right here. I have 4x to the 3rd squared. You multiply the exponents, so it will be 4 squared. And then x to the 3 times 2, 6. And so when you do the multiplication, you get 16x to the 6th power. Okay, we have a negative exponent. If I have a negative exponent, okay, look, if I have this negative exponent, I cannot have negative exponents. So if I have a negative exponent, I must rewrite my answer. And I'm going to write a to the negative m as a positive exponent. So I'm going to put it over 1 in the denominator. Okay, here's the example. X to the negative 3, it's equal to 1 over x to the 3rd power. Okay, if the exponent, the negative exponent, it's in the denominator. Look at this one. Let me go ahead and change the color. And since we want a positive exponent, then I'm going to move the a to the negative m. I'm going to move it to the numerator. And when I move it to the numerator, I'm going to force it to become a positive exponent. And so here's an example, 1 over x to the negative fifth. When I move the x to the fifth to the numerator, it just becomes x to the fifth power. Okay, what about a to the 0 power, which is the 0 exponent rule? A to the 0 power is equal to 1. In fact, any number raised to the 0 power, it's always 1. Now, if you have a curiosity of why, okay, a to the 0 power is 1, well, maybe you can ask me either during office hours or if we have to show up to class, then, we can do that. Okay, let's do some examples from here. I'm going to be selecting a few of them. You gotta have these properties handy. And in fact, I recommend you to memorize all of them. You have to memorize them. If you don't memorize them, then you're going to be struggling to be able to do the necessary simplification when you have to deal with exponents. 7 properties. Okay, so here we go with the examples. Okay, so I'm going to start with number 1. Okay, so I'm going to start with number 1. And as you can see, number 1, it says 3 times 4 to the third power. But as you can see, the bases are different, okay? So this one has a 4 raised to the third power, and the other one's just a 3. So then the first thing to do is to actually do that one. So 4 raised to the third power, that means 4 times 4 times 4, or you can use your calculator, and this is 4 raised to the power of 3. And so then you hit the equal sign. And so that will give you 64. So and this is equal to 3 times 64. And now we multiply 3 times 64, which is equal to 192. So the answer will be 192. Okay, let me go ahead and move on to the number 2. I can see that I'm going to be working with the numbers first. I'm going to be multiply the 4 and the 2. So 4 times 2, that gives me an 8. And then I'm going to be multiplying x to the third times x to the third. And I can see that they have the same base. If they have the same base, we can add the exponents. So this will be x to the 6th power. This is the answer. Okay, I'm going to move on to number 3. I can see that I have x to the 5th times x to the 3rd. They have the same base. And if they have the same base, we can add the exponents. So then this is equal to x to the 8th power, because we just add the exponents. We go ahead and move on to number 4. Okay, for number 4, I'm going to multiply the 2 and the 2. So 2 times 2, that gives me a 4, not a 2. Then I'm going to multiply the variables, x to the 3rd times x squared. Since they have the same base, we can add the exponents. So then that's going to be x to the 5th power. And so this will be the answer. Okay, let's go ahead and move on to number 5. Okay, number 5, you can see that they have the same base. The same base happens to be 6. Okay. And so then in this case, it will be 6 to the 5th power minus the 3. In your power, the exponent part, 5 minus 3. This is equal to 6 raised to the power of 2, which is equal to 36 because 6 squared is 6 times 6. Okay. Number 6, they have the same base, just as number 5. If they have the same bases, in this case, we can subtract the exponents. So this will be x to the 4th minus the 7 here. This will be x to the negative 3. But because this is a negative, I should not have negative exponents. Okay, let me go ahead and highlight that. I cannot have a negative exponent, so I got to get rid of that negative exponent. So that's going to change into 1 over x to the 3rd power. And this will be your answer right here. I forgot to box this one. Okay, let me go ahead and move on to number 15. Okay, so problem number 15, as you can see, we have a combination of two variables now, okay? So we are going to work with them separately, but it will be okay. So I'm going to work with the x's. So it's x to the fifth over the x, okay? So that's going to be x to the 5 minus 1. I'm going to leave space. That's x to the fourth power. And now I'm going to work with the y's. Okay, so then that will be y to the 6 minus 2. And so 6 minus 2 is 4, and they're both positive exponents. And so then this is the answer, x to the fourth, y to the fourth. Let's go ahead and move on to 16. I'm going to do the same thing as I did here. I'm going to consider the same basis. I have x squared and x. So that's going to be equal to x squared minus 1. Leave space. That is going to be x. Let me go ahead and look at the y's. So now that's going to be y to the 5 minus 4. And so then that will be just a y. And so the answer will be x times y. Okay, let me go ahead and move on to 17. Now, it's nice if you have the properties because number 17, if you scroll up to see which property I'm going to be using, I'm going to be using the power rule number 2. Okay, let me go ahead and tell you which one, which is this one, where we have to distribute the exponent. Okay. And so that's the one that I'm going to be using in this particular example for problem number 17. Okay, so then the first thing to do is basically I want to distribute the 3 here, okay? So that's the outside exponent. So I'm going to multiply, okay, by that 3 every single exponent, okay? Now, each one of them have their own exponents. So this one here has a 1 here. They have its own exponent. They have their own exponent. You know, each one of them have their own exponent. Okay, so with that in mind, this is going to be 4 to the third power. X, when you multiply, 5 times 3, that will be 15. Then y to the third power over 16 to the third power, x to the third power, y to the 12th power. You're multiplying by that 3 that it's highlighted in blue. Okay, now I made one simple mistake, but you know, not a huge big issue. You could have simplified the parentheses before distributing the 3, but it's okay. I will do it for number 18. Okay, using your calculator, we can work with the numbers, okay? So I'm going to use my calculator to find what 4 to the third power is equal to. And that one, it's equal to 64. And then I'm going to do the same thing for the 16 to the third power. So that's 16 to the third power, that's 4,096. I'm going to work with the variables, x to the fifth and x to the third. Let me go ahead and make this one smaller here. That represents x to the 15 minus 3. And then I'm going to work with the y. And so then the y will be 3 minus 12 here. Okay, now in your calculator, you can input the 64 over 4096 as a fraction. So let me go ahead and tell you how to input that. You are going to input 64 in the calculator. Then you are going to press the key A, B, C in your calculator. So can you find that key? And then go ahead and put the number 4096 and press the equal sign. Okay, now when you do that, your answer should be 1 over 64. And that's basically your calculator. It's simplifying it. So then this is equal to 1 over 64. Okay. Okay, now go ahead and do the 15 minus 3. That's equal to 12. So this will be x to the 12th power. And then 3 minus 12, that it's equal to a negative 9, y to the negative 9. Okay, we are not done. We're almost done, but we're not completely done. And the reason why we are not done is because we have that negative exponent. And so then I got to get rid of that negative exponent. So I'm going to move it to the denominator. Okay, here's my final answer. So it will be x to the 12. I can keep the 1 if I want to, but I don't need to. Over 64 y to the 9th power. And so this will be my answer. Okay, let's go ahead and move on to problem 18. Okay, for problem 18, I'm going to simplify inside instead of distributing the 3, and you will see that both ways it will be okay. Okay, so what do I mean by saying simplify inside? So let me go ahead and simplify in here. Okay, so let me go ahead and write the words here. So first we can simplify. Simplify means, can I divide the 5 and the 20? Can I cancel out or divide out like the x to the third and the x and the y to the fifth? And so then we can do that. So then this is equal to, well, 5 cancels out or divides the 20, and that will give me a 4. So then that will be a 4 on the denominator with a 1 here. And then I have the x to the third over an x. So if I think in my head, I have 3 x's in the numerator with 1 x in the denominator, and one of them cancels out, I still have 2 x's in the numerator left. Now for the y's, I have 1 y on the numerator with 5 y's on the denominator. And if I cancel one of those y's, I have 4 y's left in the denominator. Okay, so as you can see, I kind of simplified it, the inside first. Okay, now next, I'm going to distribute now the exponent. Now, once again, you can distribute the exponent if you want to, like I did on problem 17, without simplifying it, but then at the end, you still have to simplify. Okay, notice, I don't have to distribute the 4 to the 1 because it's just the 1. So I'm just going to distribute to the x, and then my 4 has its own exponent. Okay, so then this is going to be equal to x to the power of 8, 4 to the 4th power, y to the 16th power. Okay. So now I'm going to use a calculator. This is x to the 8th power, 4 raised to the 4th power, that's equal to 256, y to the 16th power. And there is nothing else to actually simplify anymore because we had already done it. The simplification happened before we actually did the problem. So then this is it. This is your final answer. Okay, let's go ahead and do 19. Okay, for 19. Well, I can see that that's a negative exponent, and so I'm going to move the negative exponent to the denominator. So the answer is 1 over y to the 7th power. And that is it in this particular case. Okay, these are some examples of things that you're supposed to know. And the more problems that you do and the more problems that you practice, the better you're going to become. Okay, let me go ahead and move on to the next topic. The next topic is called scientific notation. Okay, what is scientific notation and where do we use it? Okay, we have scientific notation in astronomy, mainly in astronomy, but in a lot of the sciences, there's scientific notation in sciences. And the reason why scientific notation is important, it's because let's just say we wanted it to know what the distance is from the Earth to the moon, or how fast does light travel. You know, those numbers are super huge. And so imagine somebody who's working in a lab and they have to type a number over and over and over and over again. And one mistake and the whole thing is going to be wrong. So suppose I have this huge big number. Okay. So let's just say it's this one. 3 million. And somebody has to work with 3 million. Okay. Or something bigger than that. Something like this. Can you imagine somebody working with numbers this big and they have to type it over and over and over again in the computer or the calculator? Okay, so then we are going to discuss what scientific notation is. Scientific notation is, this will be the definition. The definition says, if you can write a number, and let me go ahead and label the number A, make that number multiply by 10 to some power, where A has to be a number between 1 and 10. 1 and 10. It can be equal to 1, but not equal to 10. Okay, and your n can be positive or negative. Okay, so for example, if I can do this, then that will be in scientific notation. So for example, if I wanted to write this number in scientific notation, I have to decide how can I, generate this number by multiplying by 10. So let me go ahead and generate a pattern over here. Suppose I have 1 times 10. 1 times 10 is 10. Okay. Suppose I have 1 times 10 squared. Well, 1 times 10 squared is 1 times 100, which is equal to 100. 1 times 10 to the third power, it's 1 times 1,000, which is equal to 1,000. 1 times 10 to the fourth power, it's 1 times, 10,000. I don't know about you, but I think I can see a pattern. I can see that this is like my A. And if this is a 1, I have a 1 0. If this is a 2, I have 2 zeros. If this is a 3, I have 3 zeros. If this is a 4, I have 4 zeros. So then I can see that this will be A times 10 to the n, when n is positive, yeah? It's going to give me a number in scientific notation. Okay, let me go ahead and go back. So would it be possible for me to write this one in scientific notation? And the answer is yes, because I can see the pattern. Okay, so if I wanted it to do that, I can do 3 times, I'm going to count the number of zeros. So this is 3, this is 6. So this will be 3 times 10 to the 6th power. This will be a number in scientific notation that defines the definition here. Okay, I can do the same thing for the second number. I can do 7 times 10 to some power. I'm going to count the zeros. So then I can see that the number of zeros are 9. So this will be 10 to the 9 power. And so this will generate this number. This is a lot easier to work with. Okay, here's now the problem that I have. I said that your exponent can be positive or negative. So far I only discussed positive. How do I know when my exponent is negative? Okay, so then this will be, for example, 1 over 10 to the negative 1, because that will be 1 times 1 over 10, which is equal to 0.1. 1 times 10 to the negative 2, that would be equal to 1 times 1 over 100, which is equal to 0.01. 1 times 10 to the negative 3. This will be 1 times 1 over 1,000. This is equal to 0.001. 1 times 10 to the negative 4. This is equal to 1 times 1 over 10,000. This is equal to 0.0001, etc. Now, let me see if I can see a pattern. If this is a negative 1, I have 1 decimal place right here. If this is a negative 2, I have 2 decimal places. A negative 3, I have 3 decimal places. Negative 4, I have negative 4. Okay, I'm sorry, not negative 4, I have 4 decimal places to the left of your decimal point. I'm sorry, to the right of your decimal point. Okay, so let me go ahead and give you an example since I don't have an example with a negative exponent. So for example, how can I write this number in scientific notation? So for example, consider the number 0.00032. Okay, so I want to write this number in scientific notation. So now go ahead and observe what I'm going to do. I need to move my decimal point. And so I'm going to move it to where I can make the number between 1 and 10. So if I move my decimal to here, that is not a number between 1 and 10. If I move it to there, no. If I move it to here, that will be 0.32. That's not a number between 1 and 10. If I put it in here between 3 and 2, 3.2 will be a number between 1 and 10. And so I'm going to move my decimal point to be 3.2. So I'm going to place my decimal point right here. Times 10 to some power. Okay, now, since this is a decimal, I can see that I'm going to be moving to the left from here. So you can see that I'm going to be counting 1 place and 2. Let me go ahead and use blue. 1 and 2 and 3 and 4 places. Those 4 places is this one. Okay, when I multiply by that, if you try to input this into your calculator, if you do 3.2 times 10 raised to the power of negative 4, okay, you should be able to get the original number back, okay? Okay, so hopefully it is the right one. Let me go ahead and tell you what the original number was so you don't get confused. Remember that this was the original number. And this is our thoughts of where we're thinking where to place that decimal point. Okay, I think you understand the idea. Okay, so let me go ahead and move on. Okay, I'm only going to be doing a few of these problems, not all of them, because otherwise I wouldn't be able to finish all of them. So I'm just going to do a few. Go ahead and write each number in scientific notation. So let me go ahead and do problem number 1. Okay, so I will do problem number 1, and then you will be responsible for 2 and 3. And then I will do problem number 4. You will be responsible for 5 and 6 and 7. Okay, so it says, go ahead and write in scientific notation. I gotta write a number between 1 and 10. Now, I gotta decide where can I place a decimal point. Okay, I'm going to put the decimal point, if I put it in here, between the 9 and the 0, that is not going to be the correct place. If I put it between that 9 and 0, that is not going to be the right place. So my decimal point has to be between the 8 and the 9. And so this is going to be 8.9. Then I'm going to keep all the zeros to 9. So this is 1, 2, 3, 4, 9 times 10 to the 1 power. I'm only ignoring one of those zeros. Let me go ahead and do problem 2, just in case you struggle with this one. Okay, I gotta do scientific notation. I gotta place the decimal point somewhere with the numbers between 1 and 10. Okay, so notice I am going to pick between the 6 and the 0. So I'm going to put it in between here. So that is going to be 6.05 times 10 to some power. I'm going to count the number of zeros that I need, which is 3. And here I only needed 1. You can check it by plugging it into your calculator. 6.5 times 10 to the power of 3. You know what? I did something wrong. Let me go ahead and go back. Let me make sure I'm doing this right. I think I did problem 1 and 2 wrong. So let me go ahead and quickly fix. Yeah, I forgot to count my exponents. So let me go ahead and do that very quickly. Okay, let me go ahead and go back and count them. Okay, so once you decide where your decimal point goes, go ahead and count the places. Let me go ahead and do number 2 first. Okay, so what I'm going to do, I'm going to count all the places. So I'm going to count them here. So that's 3, that's 4, and 5. So then this will be raised to the 5th power. Okay, put it into your calculator. So that would be 6.05 times 10 to the 5th power. You should be able to get the 605,000. Now, if you do it right, then that will be correct. Now, let me go ahead and go back to number 1, and I got to count all the decimal places. So let me go ahead and erase this. Okay, we decided, or I decided to put it in there. So I'm going to count all of these digits right here. And I can see that it's 8 of them. So this will be times 10 to the 8th power. Now we're going to check it. So it's 8.9000009 times 10 to the 8th power. And when you do, you're supposed to get that number back. Okay. If we don't get that number back, then we are doing something wrong. Okay, now let me go ahead and put it into my calculator and let me see if I am doing this right. Okay, it is right, but let me go ahead and tell you that I forgot 1 0. And so you probably might be getting the wrong answer. Let me go ahead and quickly show you what I forgot. I counted the number of zeros. I can see that in here I have 4, but if you count the number of zeros in between here, I have 5. So I forgot one of those zeros. And so you might be getting it wrong. Okay, so let me go ahead and see what happened. Okay, let me go ahead and erase this. Okay, let me go ahead and write it down again. So this is 8.9. You gotta carefully count the number of zeros. 3, 4, 5 zeros. 1, 2, 3, 4, and 5. And then it's 9 times 10 to the 8th power, and it will be correct. Okay, sorry about that. Okay, so only one for you guys to do, but go ahead and let me know if you struggle with this. Okay, number 4. Go ahead and write in standard form. So if we have a positive exponent like this one, then that means to move 5 places to the right. Okay, so I'm gonna move 5 places to the right of here. So let me go ahead and do it over here. I'm gonna do 1, 2, 3, 4, and 5. And all of the spaces are going to have zeros. So this is going to be A3, 0, 1, 2, and 3, and that will be the answer. And you're supposed to be able to know how to do it by hand without the need of a calculator, but you can always check it. Okay, let me go ahead and add a few of the problems that I am missing. The ones that I am missing are the decimal exponents, the negative exponents. So I'm going to add a few here. So let me go ahead and add a few of them. Okay, writing scientific notation still here. So we can do, for example, 0.0003 and 2, negative 0.0000107, and then writing standard form, we can do 3.7 times 10 to the negative 7, and then 11. We can do a negative 1.6 times 10 to the negative 3. Okay, so let me go ahead and do the first one, and then you will be responsible for the other one. Okay, so basically what you do here is you also count the places. In this case, I'm going to place my decimal point between the 3 and the 2 times 10 to some power. But in this case, I'm going to be counting in the opposite direction. So I'm going to be counting from here on. And so then I can see that that's 4 places. So that will be negative 4 right here. Put it into the calculator just to make sure that you check that you did it right. And you're supposed to be able to get the right answer. Okay, you're responsible for doing this one on your own. Okay, I'm going to do this one since, well, no, you will do this one and I will do the last one over here. Okay, so I'm going to count 3 places. This is 3 places to the left. So I gotta move 3 places to the left from there. So my answer should be negative. This is 1, 2, and 3, and 6. And you can check using a calculator, 1.6 times 10 to the negative 3. And that should be your answer. Okay, this is scientific notation. Okay, I remember one time there was a student whose major was astronomy, and I think in astronomy they do work with a lot of multiplication and division and adding scientific notation. So let's go ahead and go over some of these problems. Okay, so I will do one of each and then you will be responsible for the other ones. Okay, so I'm going to do this one and I will do this one and then you guys will be responsible for the last 2. Okay, so then we are going to multiply the number with the numbers. In this case, it will be 9.2 times 4, then times 10 to the 5th times 10 to the negative 3. And so then when I multiply, I get 9.2 times 4 in the calculator. I get 36.4 times 10 squared. This is not in scientific notation. The reason why it's not in scientific notation, it's because 36.4, I'm sorry, 36.8, it's not a number between 1 and 10. So I have to make it a number between 1 and 10. So I'm going to change its form. This is 3.68 times 10 to the power of 1, yeah? Let me go ahead and check. Yes. And then I'm going to multiply by 10 squared. And so when I rewrite, this is 3.68 times 10 to the third power. And in this case, this will be the answer. Now, this is a number in scientific notation. That's how you're going to do the multiplication. For the division, we're going to separate. And so I'm going to separate the 2.496 over the 3.2, multiply by 10 to the third power over 10 to the fifth power. Okay, I'm going to use a calculator. 2.496 divided by 3.2, it's equal to 0.78 times, this is 10 to the negative 2 power. Okay. One more time, this number in here is not in scientific notation. In order for that number to be in scientific notation, that number has to be a number between 1 and 10. So in this case, I'm going to move the decimal point to 7.8. But then I gotta think, so do I multiply 7.8 times 10 or times 10 to the negative 1? And it has to be 10 to the negative 1 because I gotta be able to get that 0.78. Okay, times 10 to the negative 2. And so this answer will be 7.8 times 10 to the negative 3. And this here will be my final answer. Okay, you will be responsible for doing the last two problems that you see here on the paper. Okay, I am going to stop right here. The reason why I'm going to stop right here is because you can see that this is a lot of work and I need to give you time to grasp the concepts. When we come back next time, I'm going to continue with radicals. Okay? Have a great day.